Well, good afternoon, everyone. Well, afternoon here as I record this. This is a bit of a different kind of video, something I haven't done here before. And this is, I think I'll call these just a look inside. And the idea here is that I just look inside various pieces of electronics, or in this case, electrics, home electrics that have been kicking around and that seem to be something that might be interesting to, well, look inside. So this is a cheapo hair trimmer for Canadians among us. You can see that it dates back to Zellers, which is a while ago now when they still existed. This has always been a bit of a junky thing, and let's have a look inside. These are, if memory serves, really quite interesting in that they're entirely mechanical, well, electromechanical, so that because it runs off the AC line cord, it's got a buzzer circuit inside it, is my understanding of how these things work. And what that means is that there's essentially just an armature and a magnet which goes back and forth, at 60 cycles. Along with the line frequency. If we were running it with DC, it would have an interrupter in it, which is a mechanical switch that would interrupt the DC, the movement, the current, the DC current from, say, a battery source to allow that sort of buzzing motion. I remember that because I remember reading about that stuff when I was a kid and being reasonably interested. So, that's kind of gross, but okay, we'll just pull that out of there. Okay, so what we have, we've got a switch. We've got a lot of magnet wire. This is the screw that controls the end points of the motion. So let's see if we can get this out here so that we can see what we've got. See if we can understand how it works. Now, it's possible that this uses an interrupter as well, and that rather than there being a magnet on the end here, that it works more like like just a solenoid. So we'll see. Oh, we got the screws out, so let's see what we got. Nothing else, this is a nice source of quite a lot of magnet wire. So there's the magnet, right? So AC, big old magnet. And some steel to be attracted to the magnet, and a spring. So since it's not a magnet, it's going to get pulled, I guess, 160 times a second, right, as it crosses over. It's going to get pulled towards this. This spring is going to adjust how far it goes back and forth. And there's a little plastic carrier there, and that connects to the blades here, which are obviously not well sealed against the outside world. So there's the blade. That goes on, or is it the other way around? Yeah, like that. That goes on, and then that moves back and forth as this gets pulled back and forth. And then, yeah, that adjusts the spring tension, which controls how far this moves, and that's it. There's just not too much else to it. Are these? That's funny that they've got these little hard plastic pieces over the regular cheapo molded, probably ABS plastic here. I wonder if they're to prevent the ABS, that this is much harder, like polycarbonate or something. I don't know, but I wonder if they're supposed to prevent the vibration of this from gradually eating into these little posts that it otherwise sits in. Well, there's just not much to it. There's the other blade. Other side of the blade. Everything's just self-tappers into plastic. Oh, sorry, I was off camera there for a bit. Everything else is just self-tappers into plastic. So you got the blade there. Yeah, like that. That's the ground edge. Not running back and forth. And just this thing, which bzzz back and forth against the spring. The period of that being adjustable with this plastic screw. No interrupter required because it interrupts itself effectively 120 times a minute. Just double check. Let me get a magnet. I'm pretty sure that this is going to be just steel and not a magnet itself, but my hands are now oily and the magnet is sticking too hard to the inside of the drawer. There we go. So yeah, it's just steel. Either side sticks equally well. So yeah, and it's interesting they made it in laminated steel, just like the other side of this. So they've got a laminated steel, like half of a transformer arm there, that comes around. That probably picks up the magnetic field from this pole so that the whole thing is more efficient, pulls harder, and doesn't also stick to anything as steel in the vicinity. Not much to it. That's very clever. I mean, there's more than just this spring here, because this is also sprung there, and it's very tight. Like I can't. It's difficult without having it attached to something solid to move it. There's not much to it. It's very simple, as I say. It's just a magnet, and yeah, I don't have a whole lot to add to that. I would think that if this was always a pretty junky one that was hard to keep adjusted. This screw would need mucking about with multiple times, and it was difficult to clean. As you can see, it didn't seal very well against the ingress of hair and oil into the case. But that said, it did work, and for a very long time, adequately. And so, yeah, a very basic hair trimmer powered by one big old magnet, and a very clever armature. And one of the things that does keep to mind is that this has to be balanced, right? I mean, that's of course what the spring is adjusting. This has to be balanced in terms of how hard the spring pulls, how much friction there is in the blades, and that sort of thing. So there's a fair amount of engineering, or at least trial and error engineering over the course of the of the development of these things. Aren't electric razors one of the first things that were developed after the toaster in terms of home appliances? And they all would work presumably on the same principle. I do note that this metal armature is protected from the outside world with a plastic separation between it, and as are all the other sort of controls that you would use. So my guess is that that constitutes the, well, of course, then this is not, oh, it is tied to each other because that's mounted in here. So this constitutes the electrical separation to get that UL listing, presumably double insulation, so you aren't just dependent on the magnet wire and its former here. You also are protected by that, which prevents the only other piece of metal that you could possibly touch, the blades, from becoming live in the event of a short here and burning through the transformer housing. And this is just molded directly on, I think. Well, that's that. I hope you enjoyed this look into a small piece of minor household technology, and I'll maybe bring another one of these to you if people seem to be interested. Just for fun, I've reassembled it partway, just so you can see what's going on. I'm not sure whether this will work, and this is going to make a horrible noise, so just be aware. Without the weight of and friction from the blade, you can't adjust this screw, so this bangs into the armature here. Or maybe you could adjust the screw better, but not in my test. So I'll just turn it on for a moment, and then I'm going to try a slow-mo. So have a look at that. You might be able to see what's going on. So this moves back and forth like that, which creates the stroke, and this adjusts the stroke length effectively. Yeah, so I'm going to make an attempt to do a slow motion video. All right, well, that's it for a very interesting little project.